Okay, so today we're going to be talking about ordering fractions and decimals. And in order to do this, we need to know how to change fractions into decimals and decimals into fractions. So for the first part of this lesson, we are going to be working on converting fractions into decimals. So in order to do this, I want you guys to remember your favorite burger place, and hopefully it's In-N-Out, because that is going to help us with this process. So it says change 7/20 to a decimal. Divide bottom into top. Now for this part right here, divide bottom into top, I like to think of just In-N-Out. So what you do is you take your top number, that goes inside, and then you take your denominator and that goes on the outside. And remember we talked about earlier how every fraction is a division problem. So this says 7 divided by 20. This right here says 7 divided by 20. So I asked myself, how many times can 20 go into 7? And since it can't, I need to add a decimal, and then I'm going to add a 0. Now how many times can 20 go into 70? The answer is 3 times. 3 times 20 is 60. Now I need to subtract. When I subtract, I get 10. And after we have our decimal, remember we can always bring down 1 0. I like to say for free. So now I have, how many times does 20 go into 100? 5 times. 5 times 20 is 100. And when I subtract 100 minus 100, I get 0. So now I know that 7/20, or 7/20, is equal to 35/100. Now I want to show you one more way you could have seen that. If I took 7/20, I could have also said, how can I make my denominator 100? Well, if I multiply by 5 for my denominator, I need to do the same to the top, so I have equivalent fractions. 7 times 5 is 35, and 20 times 5 is 100. So you can see we read both of these the same ways. This up here is read as 35/100, it's just in decimal form, and this down here is read as 35/100, or 35/100, it's just in fraction form. So let's go ahead and try a few more. So I want you guys to try this top one on your own, 3/10. Go ahead and pause the video and try this on your own. If you get stuck, go ahead and watch, but then pause before you get to number 2. Okay, so if you needed a hint, remember the first thing you need to do is in and out. So the 3 goes on the inside and the 10 goes on the outside. Can 10 go into 3? It cannot, so you need to add a decimal. Don't forget to add it on top as well. 10 goes into 30 3 times. 3 times 10 equals 30. And when you subtract, you get 0. So this can be read as 3/10, or 0.3, which is equal to 3/10. Now let's go ahead and try this 3/8. So in and out. So my 3 goes on the inside, and my 8 goes on the outside. 8 cannot go into 3, so I need to add a decimal and a 0. 8 goes into 30 a total of 3 times. 3 times 8 is 24. I subtract, I get 6, and I get to bring down an extra 0. So now you need to ask yourself, how many times does 8 go into 60? And you should have gotten a total of 7 times. 7 times 8 is 56. When you subtract, you get a 4. You get to bring down another 0. So now you have 40. 8 goes into 40 a total of 5 times. So I know that 3/8 is equal to 0.375, or 375 thousandths. Okay, so now we have a little bit of a different one. Now we have a mixed number. So when we're working with a mixed number, we can leave our whole number, and then we just need to figure out what the fraction part is going to be turned into a decimal. So I always make sure that I put my answer box somewhere on my paper when I'm doing these types of problems. And I remember that I need to have the whole number 3. The reason why is once you start doing the division of 1/5, you'll forget about your whole number. So I always want to make sure that I keep a little side note for myself. So now I'm going to take this 1/5 and I'm going to do my long division. 5 cannot go into 1. I add a decimal and a 0. 5 goes into 10 2 times. 2 times 5 equals 10. When you subtract, you get 0, which means you are done. So this 0.2 would have to go at the end of my whole number, so 3.2 or 3 2/10. Now you could have also taken this mixed number and turned it into an improper fraction. So you could have said 3 times 5 is 15, plus 1 is 16, and then you would have gotten 16 over 5. Now when you turn this into a decimal or a number with a decimal, you'd have 16 on the inside and 5 on the outside. Sorry, that one's a little messy. 5 goes into 16 3 times. 3 times 5 equals 15. You subtract, you get a 1. You can't bring down a 0 because there's no decimal, so you need to add a decimal and a 0. And then you say 5 goes into 10 2 times, 3.2. So you can see either way, whether you turn it into an improper fraction first or you leave your whole number part and then just do your fraction part, you'll still get the same answer both times. So now we have 2 different types of decimals we like to talk about. When a division problem has a remainder of 0, the result is a terminating decimal. So an example of this would be what we just talked about, 3.2. That has a terminating decimal. It ends. Or if you had 0.86 or 86 hundredths, that is a terminating decimal. When a division repeats one or more remainders without ending, it's called a repeating decimal. So you might see something like this. If you type something in your calculator and you get 0.333 and it keeps going, that would be called a repeating decimal. And we symbolize that with a little bar over the first number or 2. So let's go ahead and try some problems with repeating decimals. Okay, so write 1 2/3, the fraction, as a repeating decimal. So what I did here is I turned this into an improper fraction. I did 3 times 1, which gave me 3, plus 2, which gave me 5, so 5/3. So now I have to go in and out, so my 5 goes on the inside, and my 3 goes on the outside. 3 goes into 5 one time. 1 times 3 equals 3. I subtract, and I get 2. 3 cannot go into 2, so I need to add a decimal and a 0. 3 goes into 20 6 times, which gives me 18 when I multiply 6 times 3. I subtract, I get 2. I get to bring down another 0. Sorry, I forgot the last one. 3 goes into 20 6 times. 6 times 3 equals 18. When I subtract, I get 2. So you can see this pattern. I'm going to keep getting 2, and then up here I'm going to keep getting 6. So you would write this as 1.66 with a line over the first 2 numbers. That is a repeating decimal. Keep going on forever and ever. Go ahead and try 13 over 33 on your own. Go ahead and pause the video. When you're finished, push play. Okay, so if you did the second one, you would have realized that you got the number 3939 repeating over and over. And although it's not the same number constantly repeating, since it is a pattern of numbers repeating, it would still be considered a repeating decimal. And that is it for lesson 1.7.1.